No, it's okay. Hello, everyone. It's a true pleasure to welcome all of you to this 12 days Python Bootcamp. I apologize for starting it a bit late. I'm 5 minutes late. It is raining heavily here at my end, and I really was thinking that to calm down small so that my voice will be as audible as possible. But I still hope that you can hear me, and I will really appreciate your feedback in the comment section if my voice is very clear. Please, can everyone hear me clearly? I get to okay. Thank you. Thank you, all those who are saying you can hear me. Thank you. Okay. But the stream is being recorded, so it will be uploaded later on. And that's when I'll pass it through an editing software so I can perform some denoising operations as well. Okay, so once again, let me welcome you. This is our onboarding meeting, and let us take a look at our agenda for the day. Today, we will discuss what we are to expect from this training, and then we will look at the setting up of our development environment. And some of you are using Windows, others are using Mac OS and Linux, so we will look at how to get all of those. And then we will also familiarize ourselves with the streaming platform. And then there will be space for Q&A, questions and answers. I must also state that I am someone who talks fast sometimes. So if I am talking faster than you can notify me as I do the stream. I also watch the comment section very much. If you have anything posted there, I will quickly attend to it. Okay. Okay, and a little bit about me, that should do. My name is Thomas. I am a software engineer, and I also double as a geospatial analyst. Well, I analyze data, but I have a background in geospatial science, so I'm able to also analyze geospatial data. I have a software engineering certificate from Hobarton through the ALX Africa program. I am also a Meta certified professional developer, and I also have some certifications from Esri. And my programming stack, these are the 3 languages that I use most of the times. I can write other languages also when need be, but the 3 I use the most. That's which I employ in cross-platform mobile development using Flutter. And then I use Python 2 for web. I use it for analysis also. Most of my analysis is done with Python. And JavaScript is for the web stuff. If you are looking to connect with me, you can do so via LinkedIn. That is the social media platform that I give most of my attention to. And then I also run a YouTube channel called Tommy's Codebase, where I teach everything about software engineering. And I'm currently a member, a very proud one for that matter, of the Geospatial Innovation and Research Center, located at the Kwame Nkrumah University of Science and Technology, Kumasi, Ghana. And I've been through very capable hands who have trained me to become the person that I am right now. And I'm privileged they are with us together today in this stream. My very own supervisor, Professor Samuel Atu Andam Akofo, who is an associate professor of geospatial science at the Department of Geomatic Engineering. And Dr. Samuel Osas, who is with us, he is also in the Department of Geomatic Engineering. And these two people have really trained me to be the person that I am right now. And so now to what we are supposed to expect. Well, there will be about an hour live webinar for the daily sessions, as you saw in the registration. So that will be from Monday to Friday. And this will be done at 6 p.m. UTC or 6 p.m. GMT. So there will be live webinars like this that is happening. You just receive the registration link, you register, and then when it is time, you just hit the link and it should take you to a place like this where we will have our live sessions. Okay, for those of you asking whether the stream will be uploaded, yes, it will be uploaded, so don't worry about that. And then you should also expect to become confident in using Python for geospatial analysis. If I should tease your mind a little bit, it will interest you to know, if you don't already know, that most of the GIS software you use, like the popular ones like ArcGIS and QGIS, whenever you click a button there to maybe clip a raster or to perform a buffer or anything like that, what does the job behind the scene is Python. And we will see it when we open QGIS. You will see that there's Python there. When you run any analysis in QGIS, don't be in a rush to close the window. Look at the window that will pop up, the processing log. You will see that it is calling some .py files. Those ones are all Python files. So it's Python that is doing all this job for you. And trust me, if you know your way around Python for some of these things, you will be very efficient in the things you do with geospatial analysis. You can automate workflows. What you can use like 20 days to do with click and drag can be done in like 10 minutes if you know how to use Python for such analysis. Also, there has been so many concerns about the certificate of completion or some kind of proof of participation. Well, this is the second time I'm organizing a bootcamp. The first one was for core Python, which was in February of this year. And what I was doing was that I was giving weekly assignments for participants, and then I'll go through market and grade them. And then after everything, those people who passed with a certain mark were given certificates. But other people who were making my job very difficult for me, they were doing the work completely with AI. They would just paste the assignments in AI, copy the code, and come and paste it for me. So it was making the job very difficult. So there will be a proof of your participation. But that one, you will have to prove to me that you have really learned how to use Python for geospatial analysis. So what I will and can do is that you will have to do a project at the end that should be submitted within a particular time period. And if you submit the project and the organizers review it and you pass it, then we can issue you a certificate or grant you space on our website so that you can host your project there. So that if you have to prove to anybody that you've done something like this, you have something to present for it. So just stay in touch and then do your best to learn as much as you can and understand the principles that we will be teaching here so that you can build something that will earn you a certificate at the end. Now to the setting up of our development environment. We'll be using these tools. The first one is Conda by the Anaconda distribution. That will help us to get the Conda package manager on our PCs and then use it to create our environments and then install our packages. If we let's just do a quick search on the Anaconda website. So you just search for maybe Anaconda like that, and then I'm just hoping it will not throw up a big snake. Okay, exactly what I was looking for. This is what we'll be using, the Anaconda distribution. Especially for Windows users, I'm currently doing this stream on a Mac, on a Linux environment. You don't have to use Linux. The code is platform independent, so you don't have to use Linux. But especially setting up your stuff on a Windows PC can be challenging. So these packages like Anaconda, there's one that I've not explored before called, I think it's called Mamba, and there's also what we call for Windows, the OSGeo4W, which is the open source geospatial foundation for Windows. So we use this package manager. Anaconda has a repository of tried and tested Python libraries, which we can install and use without having any problem that comes with trying to set up our own environment. So we'll use this one. And because most of you are on Windows, others also are on Linux, I can't teach you how to install them in this onboarding meeting. What I've done is that I've recorded separate videos for each platform that will teach you how to do it on your platform. And then when I'm uploading this stream, I will upload those ones also so that you learn by the video how to set up your environment and then get it working before our first meeting. So for today, I'll just take you through the things that we'll need, and then the videos will guide you through the installation. And also, we'll need what we call a development environment, where we will type our code, where we will edit it, we'll see our output and all of that. There are so many options available when it comes to Python development, but the one that you will be using, and that I'm choosing that because one, it is lightweight, two, it is completely free and open sourced, and that is called Visual Studio Code. I don't know why it's not, it doesn't show when I type in that big box, but this is the editor of choice that we'll be using. And so if you're already a developer, you probably know what this one is. So we'll be using Visual Studio Code also. Once again, you can pause on the installation, the video that I'll upload later. Immediately after this stream, we'll teach you how to install it. But for the other stuff that we will have to do, like the QGIS also, that one too is an open source GIS software that we don't need to pay anything for. So if I'm to search in this big box, I'll just say QGIS. And then it says here there's spatial without compromise. So a group of people decided to make the software for free. So the video as again will show you how to download it and then when we are supposed to use it. You can see it's also cross-platform on its own. And then apart from this tool, also we need some Python geospatial libraries. And there are a lot of them that we cannot cover in this 12 days period. So the popular ones that we'll be looking at, we have one called Shapely, or let me start with Funa. Obviously not the one I was looking for. Let me just say Funa Docs. Okay, so this is it. You don't have to understand whatever is here. That is why we are organizing this camp. I will explain everything when we are actually using Funa. For now, I'm just introducing you to the things that we will use and learn. So don't panic. It's just very, very simple. You get to understand it and appreciate it very much. We use shapefiles and geopackages. And so this is the tool that will help us to deal with our shapefiles and geopackages. Whether it is reading and writing, it says here that Funa can read and write real-world simple feature data using multi-layer GIS formats. It can even read zipped files and files that are in memory, like virtual files, files that really do not exist in a, should I say, a physical space, but it exists virtually or temporarily in some memory, but not on a location on your hard disk or computer. Funa can read all of them. So we'll be learning this package, how to use it to open, how to use it to create shape files from scratch. So let's just keep that one to aside. We will also be, let me open this one on a different page. We will also be using one called Shapely. So let me just add docs so that it will know that I'm searching for this one. So this one too, this is Shapely's website. Okay, this one is taking a while to load. Okay, I don't really know why it is taking that long, but we will also need one called Folium. That one too will help us make maps. So visualizing like geospatial data in the form of maps, interactive maps, and all that. That should be the job of Folium. There's also a Python library that will help us do all of those things with ease. I think my internet is a bit slow. Okay, that is one of the disadvantages of live sessions. I cannot crop this part out, so please bear with me. And the next one that we will be using also is Rasta. People say Rastario, Rasta.io, whichever you pronounce, you are welcome. And that one is a Rasta package. But even before I introduce Rastario, let me introduce GDAL, which is the Geospatial Data Abstraction Library. This is the library. QGIS uses it. If I should open it up, because you have not installed it, I don't want to go ahead of myself. But I think our Folium is ready. If you know Leaflet, or if you heard of Leaflet before, it's a map provider. And Folium here can help us access leaflets, some of the leaflet stuff, and create maps using Python. So we will learn how to also create interactive web maps using Python Folium package. And then this Shapely has also opened. What Shapely will help us to do, I think it builds on, should build on Funa. And this one gives us more functionality with the shapefile than Funa does. I think Funa gives us a simple access to read, write, but if we take a quick glance at this documentation, you see that it's quite a lot, and we can perform things like the buffer area and all those things that we normally do to shapefiles, all those properties. Shapely is what will help us access all those things, as we will learn very soon in the sessions that are yet to come. So we use Funa to read, write our shapefiles, but when it comes to interacting with the shapefile, performing analysis related to geometry, topology, measurements, and all the things that are here at the left side, then we'll be using Shapely to do that. For the raster packages also, there is this one called GDAL, which is the Geospatial Data Abstraction Library. This is written, I think, in C or C++, C++. And so it's, some of its concepts are a bit difficult to grasp, if I should be very honest with you. So we can use this one also. In fact, we will try and use it 1 or 2 times, maybe for some raster stuff like raster vectorization and all that. But if you find GDAL to be difficult, these guys who wrote Rastario or Rastario have simplified that operation on raster and the complexity of GDAL. Let me see if they say that in the introduction. I'm expecting them to say it. They have simplified how to use the GDAL. It actually builds on GDAL and allows us to do the things that GDAL will do in a more Pythonic way. I think they stated it somewhere here. It says before rasterio, there was one Python option for accessing many different kinds of raster data files using the GIS field. The Python bindings distributed in the Geospatial Data Abstraction Library, as I said. So this is what was used for raster analysis in Python when rasterio was not yet on the scene. But these Python bindings, as you are seeing here, said this is bad. Among other considerations, we've chosen Python instead of C to avoid problems pointers. If you are somebody who have an idea of the C programming language or even C++, and you have to deal with pointers, manage memory addresses, know when to like delete and manage pointers, is a whole lot of headache. And if it comes to reading and writing heavy files like rasters into memory, when we get to rasters, you will understand that a raster is just a grid or an array of numbers. You can see it as a big matrix of numbers, and so it's quite heavy depending on the size. And if you have to manage memory addresses using pointers and everything, it is crazy. It is really, really crazy. Yeah. So in order for us not to confuse ourselves with those C concepts or even have to learn very hard ways of doing things, these guys have taken GDAL, built upon it, and brought up this very nice and cool package called rasterio. It helps you to do all the GDAL stuff in a more Pythonic way. So this is what we will also be using for our raster analysis. We will even go ahead with some very practical examples like cloud masking, which is a bit difficult to do in ArcGIS and co. Rasterio can help you do that easily. It's fairly straightforward, like vectorization, like the creating, reading, updating of rasters. Even raster vectorization, it can help us do it. It can help us visualize our rasters, create merge, composites, and everything that we do in the GIS softwares. And one other important Python library that we'll also be looking at is called Geopandas. This Geopandas, I chose to bring it last because it is one package that kind of includes all of them. In the video that will teach you how to set up the environment, you see that I even told you to just install Geopandas. Because this team which built Geopandas, if you are familiar with data analysis in Python, then you know the Pandas package, which is a powerful data library that helps us to do a lot of things with tabular data. So if you look at geospatial data, all that you can think of is maybe data that has geospatial components. So there's an XY column that will help you analyze the data spatially. Okay, this one too is now loading. The way this internet is taking a long time to load pages, I just hope that the stream is very fluent. Okay, I will let this one load and then I'll move ahead and then look at other stuff also. Okay, so this one, as I said, the videos will show you how to do that. And also familiarizing ourselves with a streaming platform. The streaming platform is StreamYard. Every day, the link for the particular day's webinar will be sent to you. And this is how it works. You have to register for the day before you can get access to the link to join this stream that you are watching now. So tomorrow, the link will also be in again. Don't think that because you registered for today, you can use today's link to join tomorrow's meeting. Every day you have to do the registration, and so take note of that. I am viewing the admin page, so I can't really tell how your page should look like. But if you are looking forward to send me a question, then you can do that in the comment side. There is also a private chat. If you think that I am the only person who should see what you are sending, then you can choose the private chat side to send me that particular message. As I watch my second screen, I also watch the studio for your comments and questions. Okay, so that should be, we should enter Q&A soon, but let me see if Geopandas is successfully loaded. Okay, Geopandas is in. So you can see here from their website, they say Geopandas is an open source project to make working with geospatial data in Python easier. So it extends the data types used by pandas, and one of the things I love about pandas is the data frame. Their data frame is so powerful. I've not seen anything like that. I think there's one package now that is competing called Polaris, but still Pandas is leading it by far. And so it extends upon pandas to allow us to perform geometric operations with geometric data types. You see here that it has mentioned Simply. It has mentioned Pi. Some of these packages, their names are very difficult to pronounce. I don't know how to pronounce this PYOGRIO, but Matplotlib, I can pronounce it. It didn't mention all the packages it depends on, but it depends on all of those packages, including PyProj, which I did not search for, but we'll be using for our projection stuff. It's called PyProj. So this one too is here, the PyProj documentation. That will also help us. We'll be using it for our projection. So the coordinate reference system stuff, we'll be using PyProj. And so we see here that I think I was expecting it to go a bit detailed, but it is not really going into detail. And that is one of the things with documentation. If you are a beginner, then the documentation may not be the good place for you to get started. And that is why this bootcamp is being organized. I will show you exactly what to do and where to find what you need at what point in time. So this also PyProj is an extension or the Python interface to Proj. I told you that most of these, or even all, are mostly written in the C++ language. And so we will need a Python interface or API to be able to use it in Python. And one of the reasons you want to choose Python and not C++ for such analysis is the availability of such powerful libraries like Pandas and NumPy, which we use a lot in this series. They just make data analysis so easy. They are so powerful. So these ones are originally written in C++ and C. I was expecting to see it somewhere here. But PyProj extends Proj, so as a Python Proj or something like that. And it will help us to do our cartographic projections and coordinate transformations also. We've looked at Folium also. So we don't need to look at PyLeaflet. Okay, so those are the packages that we'll be using. And for we'll be performing some classification also. And so some of those raster analysis like interpolation, classification, supervised and unsupervised, we will need this particular Python package called scikit-learn. It contains a lot of the machine learning libraries. It's a machine learning library, sorry, but machine learning frameworks or models that we can use to do our projections. There is also one called TensorFlow. This one too is a machine learning platform, and okay, my scikit-learn page doesn't want to really open. But don't worry if you don't know anything about machine learning. We are not doing machine learning here. I will not be explaining machine learning concepts. I will not be explaining the formulas here. I will just teach you that if you want to do this classification, you use this, and this particular parameter we are passing is for this and that. For those ones, I will explain it to the core for you to understand. But this is not a machine learning class, so you don't expect me to be teaching you what is machine learning. Okay. But because most of these classifications, like the random forest, classifier or random forest, let me choose the classifier here. You see that when I search for the random forest classifier, it automatically even brought me to the scikit-learn page for the random forest classifier. So that is why we'll be using the scikit-learn. I'm sure if I search for support vector classifier too, that should take me. Okay, okay. It also has support machines on scikit-learn. So that is why we'll be using this package when we get to the classification side of things to do our classification, because the models that we are looking for are all inside there. Okay, and there's also one called SciPy. It's a Python package. That one in particular will help us to do things like the interpolation. If you want to do something like the inverse distance weightage, it's SciPy that we'll be using to do that. Let me close these ones. We already know that they are inside scikit-learn. TensorFlow will also assist us. Okay, so this is also SciPy. Maybe you can think of it as scientific Python. So most of the scientific computations can be done with that. And you can see here, this one is also written in C++. So those are the packages that we'll be using. Once again, I'm assuming that we are all starting from scratch. If you have knowledge in any of these, it's a plus. But if you don't have knowledge in any of these, don't be afraid. At the end of the 12 days, you'll be a confident Python developer, especially in geospatial concepts. I've done a lot of freelancing works, but because of confidentiality, I cannot share them here for you to see. Maybe if I get permission from the people, I'll share some of them as we go along. But you can use Python to create maps. You can use Python to create interactive maps, web maps. You can use it to perform analysis. It gives you that ability to easily handle your data. And then if you need to perform the same processes over and over again, it's just a matter of running a script. You don't have to open your software, save new files somewhere. Just run a script, and then everything you need will be there waiting for you. So that is it about the introduction to the packages that we'll be using. I don't know whether there is a... Okay, I see some comments. Let me see if there are questions that I'll have to... Okay, someone is suggesting that I use Google Chrome. I'll use that. I will use that. Because I don't think my internet is slow. So I was not understanding why it was taking a long. Okay, when will the environment setup video be available? I couldn't upload it because this session has not been done. So immediately after this session, I will upload it together with this particular one that we are recording. And then you can have the two. Okay, so someone is asking for the link to that core Python. Okay, let me take the suggestion and use Google Chrome for this one. So if you go to YouTube, okay, so there's a question about downloading the libraries now. Please don't download it now. There's a video that will show you how to do it. Okay, it's asking me to select an account, but I'll select this first one. The video will show you how to install it. Someone is concerned whether we should install all these libraries. Yes, you need to install all of them because you need most of them at once to do what you want to do. So yes, we need to install all of them, and most of them depend on each other. If I should bring back my space, if I open Geopandas, you see that it is mentioning Shapely over here, but Shapely in itself is also independent. Where is Shapely? Shapely is here, is independent. And Shapely is also mentioning Geos, and so they kind of depend on each other. So yes, if you install one, you need the other one for it to also work. Folium is getting data from leaflet. GDAL, I don't really know about that one, where it is. I'm sure it was written from scratch, but Rastario is getting it from GDAL. Proj or PyProj, sorry, is getting it from Proj. So yes, they will look many, but you need all of them for the things to work. Okay, so YouTube, I think you can search for the name of the channel is Promise Codebase. I think it should pop up here like this. This channel, that is where I will upload this stuff to later on. So there is very first one with this green logo. You just click on it like this. It should take you to the page. And among the playlists, you come to the playlist side. You should see this is the 21 days of Python bootcamp. So everything that was done was there. So you can go through it if you want to brush up your Python skills and get things started. So that was it. I think I don't, because that is where the stuff will be uploaded. So once you go to the channel, you can all of them there. Okay. Someone is asking whether you need a phone to, whether you can use a phone for this this camp. That I cannot give a definite answer, but you can. I think Drive, Google Drive. I don't know whether you can access that part of Google Drive on your phone if you don't have a PC. Yeah, I saw that there are some of us who don't have PCs. But there's this package that this app that Google has that is called Google Collaboratory. And that one, it will help you to run some code in the cloud. So I think I have my collab notebooks here. And if you have a Google account, you can create a collaboratory notebook just by coming to the new button at the top there. And then I think you choose more. And if you see Google Collaboratory, this one is online. It's not like the Visual Studio Code that you install that you have to get it locally on your PC. This is online, but I've not really tried using a phone to type code inside Google Collaboratory before. But maybe a tablet with an extended keyboard might do the trick just fine. Does computer specification affect the running of these libraries? Yes, to some extent. Because if you are analyzing heavy rasters, then you should Sorry, I lost connection. I've lost connection to my monitor, so I'll have to manage this one like that. You don't really need that powerful of a machine if you're not doing some very, very strong analysis. Uh, but if you are analyzing some very heavy files, like very big rasters, then of course you need a powerful machine to do that. Uh, but if your analysis are not that heavy, you don't need a powerful machine to do it. Okay, I think most of the other questions are very similar. So like something like when where to install the libraries, how to do it, and all that. But as I said, the video will be uploaded teaching you how to do all of those things, so you shouldn't worry about that. Okay, the page you are seeing now is Google Collaboratory. And so it's an environment that Google provides where we can run our code for free. And this one, you don't need to have a very powerful computer in order to run it. You just have to have a Google account. So like you see it here, if I should zoom in, I know I'm getting ahead of ourselves, but you see here that it says start coding or generated AI. So it already has Python installed. So if I choose to type something like print and then put in here hello, which is the command in Python we use to display stuff on the screen, you should see here that it's running, and down here it is connecting to the Python 3 Google engine backend. So once it's done connecting, it will show me my output. And so if VS Code does not work on your system, the system is not that strong enough, you can fall on Google Collaboratory, the same code, and this is what a Jupyter notebook looks like, and then everything should work for you. But in this case, you have to be working with the files online, so then you should upload them to your Google Drive or store them somewhere online and access them via their URLs. So if I say print rather hello world, so that the output now changes to hello world. Okay. Okay. So I think it's 43 minutes, and um, that should be it for an introduction. Except there are a few questions that I'll still have to answer. And unfortunately, this platform does not allow you to communicate with me via voice. So you will have to type your, your question. But if you still think that it should be via voice, then you can send it to me on WhatsApp, and then I'll find a way of listening to it and then replying. And because I understand somebody is asking, is Windows 7 able to install all of this? I okay. I've not really seen somebody using Windows 7 for this, but yes, these things that we are talking about, they shouldn't really be dependent upon the type of your system, whether it's an old Windows version or not. Once you're able to install the software and the Python packages, you are good to go. But if all of those things are even failing you, you can resort to Google Colab if you have a Google account. Someone is asking whether you can do this in R. Yes, R can do most of these things. I love R. I use R, but I don't use it that often. It is good. It is simple and powerful. But one of the reasons I choose Python over R is because of the packages. I think that R packages are not so stable. Today you write a script using this package. The next day you go and you are installing the package again, and it doesn't even exist in the repository. they've placed it under another package. You have to go and install that package and all of those things. But that is powerful. I love it. I use it. But because of the stability of, let me say so, Python packages, I prefer to use Python for my analysis because these packages, they have been there since that is their name and they don't really change. They only update them to better version. Okay. The type of powerful machine I have in mind is it's dependent. I am currently where's my processor? The sticker is gone, but I have a 16 gigabytes RAM and a 2 terabyte Samsung SSD. I think it's the NV something something. So it's a bit faster. It runs my applications faster, and because of my RAM memory stuff also performs faster. But maybe you don't have that flexibility, and so the term powerful machine is purely subjective to everyone of. Okay. If I skip your question, please, it's not really intentional. A lot of them are coming in, and I have to look at all of them. So the YouTube, the channel's name is this one, Tommy's Codebase. Uh, is this place? So maybe I should link it in the WhatsApp. Okay, so I'm putting it inside the WhatsApp page so that you can click on it and visit it. And let me close this one. Okay. So, friends, let me say that will be the end of today's session. And I'll upload the video immediately, as I said. I will have to now download it, take it to the editing softwares, and then do one or two denoising and all that. But I'll upload it before the break of day, like the morning of 15th. Some of you are already in 15th October, but whatever time and date I mentioned is with respect to the GMT 0. So that means you will have it maybe in about 3-4 hours time, depending on the time of. Okay, so I will list all the software in one message, and I'll also prepare some documents for you, PDFs. Maybe that will simplify things for you. Some of you have to read and take time and digest it. I understand it, so everything like that will be provided for you. If you have any concerns too, you can put it on the page, or if you think it should be very private, at any time you can enter my DM. But you have to, when you send me private messages, please be mindful of the time zone. I might be sleeping at that time, or I might even be online, but in a particular group for another meeting or doing another thing online of equal importance. So forgive me if your reply also doesn't come fast. I reply as quickly as I can. Okay, so that will be all for today, friends, and I'll see you tomorrow and the days following, where we start diving into Python for GIS and remote sensing analysis. Until then, stay safe and it's goodbye.